Welcome once again. My name is Joshua France. I'm here in Orlando, Florida, working remotely during this exciting adventure we're all on together. So we're going to talk about RiPROCESS and how we handle our cameras and imaging. So we've added a tool to improve your image quality on the post-processing end. And a lot of you are nodding your heads right now, I'm imagining, going, yep, we've had issues with that. So one of the things we have to start with is we have to talk a little bit about the acquisition side, because in order to have great pictures, you can't make a picture really that much better if it starts off really poor to begin with. So what I want to start with is what are some tips and tricks for getting better quality images to start with, so that way in the post-processing you can really maximize what we have available to you. Okay, so what are we trying to do here? So as you can see from those image results there on the right, we have a wide variety of different conditions. They're underexposed, they're overexposed, and they're blurry. So all of this can happen occasionally. We hope that it doesn't happen to you, but sometimes there's folks in the field that get a little rushed and they're trying to find one-size-fits-all settings when the lighting conditions are dynamic. And because they're dynamic, they're changing constantly. So we try to give you some suggestions to allow the camera tools that are built into the actual camera sensors to work for you and not against you. So let's start with just looking at our trade space here. So things that we can control are how fast we're driving. We can control the gain of the camera, and we can control the exposure time. What we really can't control, and our kind of constants, are the daylight conditions. You know, between any given day, it's going to change. The shadows from trees are going to get in the way from buildings. All of this is going to change the way the light interacts in the photograph. Not really something you can have anyone control. You can consider, of course, when you start your collection, the sun angle and things like that. And hopefully, if you have an opportunity to collect during a cloudy day without rain, then you would do that so you have consistent lighting conditions. Then object distance. For airborne folks, this is easy because they're flying at a fixed altitude height, and the variations are minor comparatively to the mobile scan system, where you're driving along at a highway speed and objects are coming and going near and far away from you all at once. So you have to kind of pick a happy medium between where you would like to see things clearly and where you can see things clearly. So how does that work into our trade space here? So if you increase the exposure time, it's great. That's one of the things you can do. But it decreases sharpness caused by higher motion blur. So, okay, now you got to slow down. Well, when you slow down, it improves exposure without increasing motion blur. However, now you're driving slower than everybody else, so you can see more car noise. On the practical side, or it takes longer to collect data. You can increase the gain, but of course increasing the gain also increases the image noise, which makes it that fuzzy color. So grain is a perfect word for it. So the next step is, okay, now if we want to improve motion blur, we can decrease the exposure time, right, which increases the gain, and we can decrease platform speed. So everything interacts with each other. So decrease platform speed, you can get really good quality images. If you increase the gain, you might improve motion blur, but you get a noisy image, you get a grainy image, in other words. And if you decrease the exposure time too much, you get really underexposed images. So there's a lot to consider. So let me help you out here. This is what our camera parameters look like, which at first look, you're going to go, that's a lot of different adjustments, right? Yes, there are some options. There are a lot of options here. Now, the good news is that the only ones you can adjust really are, let me get my pencil on here, pen, is these right here. These are the ones that we're adjusting, okay? And same with these. okay? So it's really just 6 parameters, okay? And this part, we actually don't give you that option. So it's just 6 parameters, 3 in the exposure control and 3 in the gain. All right, so let's talk about each of them. So now the top 3 in each of these boxes, so the exposure auto, exposure mode, and exposure time ABS, those are going to be the current values. They'll be displayed and adjusted as you make changes and apply them to the cameras. So I guess the first thing to let you know is that if you want to see what camera, which camera is which, you have to go down to this button here in RiAcquire. So now we're in RiAcquire. Back up. This is under camera settings. So on the first tab is common. That's where you would set up your trigger mode, whether you're going to do a distance triggering or a time-based triggering. That's where you would set that parameter and apply it normally to the cameras. All right. So this is then that second tab, which is settings. So in the actual settings here, you can use this drop down and you can read from each camera. So in this particular case, it's showing us that right here, these are the values from camera port 9. And as you notice, you have apply and apply all. So you can apply just to a single camera, or you can apply it to all the cameras all at once. Typically, because if you have cameras on different sides of the vehicle, you should try to apply it just to one camera at a time. So this gives us a bit settings. So one of the first things notice is that our auto gain default here, the maximum is typically 50%. And so our first recommendation is we lower that down to 40, right? Because then this brings the gain in too fast, right? And if it's too, so that's the first thing that we change, is we adjust the default setting. All right. So let me clear my drawings here. So I went to the next page a little bit too fast. Erase all drawings. There we go. So for the control or the exposure, we set the auto control, right? And we set it to about 20. So you go back to this, we see this is set to 20, right? And then we're going to change the maximum, okay? This is based on the lighting control. Oh, too far, sorry. So, and in this case, I did a quick sample of 120 microseconds, which is calculated based on blur, which is determined from the speed, the target distance, and the focal length. So at 60 miles per hour, so I'm driving on a typical American highway. At 25 feet, so I'm looking at stuff probably off the shoulder, maybe highway signs or a little bit further away from me. And I'm using our 12 megapixel cameras, which have an 8mm lens. So that's how I was able to calculate that. If you attended our training symposium, you should have got as part of the materials an exposure and time calculation Excel file that I made for everybody. This also helps you calculate the size of each photograph. And it also helps you determine your frame rates. So if you don't have that, that's something you can email me for. I'd be happy to send that out. I'll also try to include that with the package of information I send you relating to this webinar. So that's on the exposure control side. So this is the value that's going to adjust based on what you're aiming for and how fast you're driving, okay? This 20%, that's sort of a feel. That's a recommendation for typical conditions. So it's a sunny-ish day with some cloud cover, about 20%. If it's a little, you can adjust that as you see fit, and you'll see results immediately. But this number here is the big number. Adjusting this will improve the images faster than anything else. So on the gain control side, right, we're going to aim for 10%, and we're going to actually lower it even further from 40 all the way down to 30 is our recommendation, to not let it go over 30% here, okay? Again, I have a quick PDF on all of this information that will also make sure I include in the information package from this webinar. All right, so that's a quick summary of how we want pictures to look while we're acquiring data. So without too much more explanation here, we'll get right into it here. So this shows you the setup of the car during the data collect that I will go to in a moment. So you can see we are using 2 of our RIEGL 12 megapixel cameras, and we have the Ladybug up front. We're not going to look at the Ladybug data today. It is there, but we're just going to focus on the RIEGL 12 megapixel cameras and the image quality we get and how we can improve them. All right. And I did my best to adjust the parameters that we just went over to make them look really great on board the car. A little bit underexposed is our preference. So let's Teamviewer into my computer. All right, let me make this full screen. Just make sure that the audience view is updated with me. Just a moment. Yes, it is. All right, perfect. All right, move that back. All right, so I'm on my remote machine. As you can see, I can control it. All right, so we brought up a picture. So this is from our camera 2, and you can see we pulled quickly into a office park area. So happens to be very similar to the office park that RIEGL USA's office is in. And you can see the lighting conditions change as you go around the block there. And this probably looks better or worse depending on the monitor that you're looking at. I've noticed. Let me increase my brightness a little bit. But I think we can all agree that this picture is a bit dark, and it's changing, right? And this is exactly the kind of case that we're going to encounter as mobile mappers out there on the street, where you get issues with that because we can't control how the light interacts with buildings. So what we're going to do is we're going to close this file. And this is, as you can see, it's RiPROCESS 1.8.6.8. Okay, so this is a pre-release version. And we're going to go into, I believe I was looking at camera 2, but we're going to do both. We're going to go edit. And we're going to go into our processing tab, okay? So this is already after we've done our mounting calibration, where we've calculated the mounting XYZ location and rotations between the camera matrix and the IMU. So that's all completed. And now we have this new button here called Activate Histogram Based Adjustment. And we have several choices here to use. And we're going to use the horizontal orientation because our cameras are horizontal. Now this has an import mask. So if we had part of the car in the view of the camera, we could make a mask that would black out the car so we're not using the car's color to adjust the histogram to. Right? Or if there was a part where you had all sun up in the top corner of every picture because of your direction of travel, you could block that out as well. And I'll show you how to do that in a moment, but for right now, let me just apply this and click OK. And now we go back to our same photos from camera 2 here. And it's going to take a moment to load. And you can see that it's done a color adjustment very clearly from what it just looked like. So this is making it much brighter than it was previously. So this was kind of dark in here. And remember, the goal of taking images with a mobile mapping system isn't to win a photo contest. It's to allow your folks doing feature extraction to find features that they're looking for. That's what we're aiming for here. We're not looking to make, the cover of a magazine or win a photo contest. We're trying to maximize the value of that data, right, down the line. So as you can see here, we had that light to dark shadowing. Now that's gone. All right, just bear with me here as I jump through these photos because, let me turn that off real quick, because we're a little bit delayed thanks to the remote as I'm sure everyone is having fun dealing with these days, being remoted in from your remote location. So, but the internet's holding up quite well. So we can see here, these are loading, and it is a 12 megapixel image, so it does take some time for the processing to happen. Now you notice I didn't pre-process any of these images. I clicked that button and reopened them, and they were processed, so there was no time lost, right? It didn't take 2 hours or 3 hours, and I'm just, cooking the books here. This is live. If there was someone else in the room, I'd have them confirm that I had just done that, but really, this is that fast. So it's just the time it takes to load the images. right? So there it took a little bit longer, but you can see our shadowing is very equalized. Okay, let's see some features like power lines, because I mean there's power lines in this photo, but they're way behind this. I mean the LiDAR data can see it, but you're not going to see power lines through. Maybe you can see them. They're right there. And I can draw with my pencil real quick. My pen here, I can extract them for you. But this obviously wasn't the point of this collect. So let me move down the road here. I can take my drawing tool off. There we go. To a different location. I found out already that if I don't close the photos in between sessions, in between areas, it takes longer for everything to load. So let me jump down to, I think this street was gonna look pretty interesting. So again, it does take a few minutes for it to load, and you can see the colorization there loads in. Now, if we want to compare what the lighting conditions were, it's not quite the same because I don't have two cameras on the same side. I have one camera on each side. I can load this up from camera 1, which is looking at the opposite side. So you can see right here the difference between the two. So camera 1 has not been process adjusted. That's on the left side of the screen. On the right side of the screen is the new image processing. So you can just step through here and you can see, so let's take a look at this picture in further depth. So we can zoom in here and this comes out quite clear now. So out of curiosity, I'm kind of curious, could we see this as well in the original before we process this? So this is 5. This is image 5 in this series. Let's close this out. Let's find out. So we're going to go back to camera 2. We're going to go to processing. We're going to deactivate it. That's all you have to do. Go back down. So we're down here in Vanguard-5, camera 2. And we're going to close that. We go to image 5. Let's see. You know there's power lines in there, but you can already tell it's a little darker. So you can, but it's not as clear. So it's arguably not as clear. It's still clear. I mean, you can still see it. But certainly in this area right in here, where you zoom back down the line a little bit, it's definitely harder to pick up, and it makes it a little bit busier. Some of this detail is okay, but with the adjustment of it, it makes it pops to your eyes better. And if you're training an algorithm, you want it to sort of pop to your eyes better. All right. So even though even though I know this, as we're going to turn the corner here, that sun's going to go away for the most part. Well, let's crop out the sun, shall we? So we go into this tool here, and we're going to crop this out right here. Right, so that's going to sort of create that mask, and I'm going to hit save. So again, all I did was I created a match for color correction. I hit save, right? It should save that. I was hoping it was going to ask me where it would like me to save it. Let's open the import photo here. I'm also going to save one for this as well, just so I don't have to come back and create one for this as well. Save. Okay, it's saving it. Okay, so now when we close this out, we can go back to camera 1, edit, processing. We can activate that for this, right? Import mask. Let's see. That seems to be the right one right there. That's a CCM file. Let's see what happens. Well, I wanted to import it, so they're right. It's not the same. No, that's all right. Well, let's activate that. Camera 2 here, again, let's turn back on the active adjustment. So now we can go back in, and that's how it works. So it looks at each of those things. There are some further ability for us to make adjustments to the overall algorithm, sort of behind the scenes, that we can do. But at this point, I think the basics are going to get everybody started off for the most part. I think this is marginally better, but perhaps it's still a bit bright due to that sun. So in this one, a different setting might be needed. But again, you can still see everything in the photo. You're not losing out on great details. You can still read most of the information on this car. The phone number is still clear if that's what you were looking for, so that's still good. If we go over to here, it's definitely a better color contrast across it. It reflects the very bright day that we were having with the clouds suddenly disappearing with us. Again, just got to load that in. But that's the basics for this camera module. So again, having the proper acquisition settings is critical. You do need to do your best to enable ones that work for your lighting conditions on that day. You do need to adjust the gain setting way down. So it starts at 50% by default, and you should try to push it. You should push it down to 30% as our recommendation, if not a bit further in some situations. And then adjust that exposure time to match your driving speed. Right, that's very critical. So if you're always going to be driving the same speed, it'd be important to get that calculated correctly. All right, so that's this part on image processing. So and then these new updated images with the histograms adjusted do get exported just like the other photos do. You can export them with their lens distortion modeled for like a topo.export. export, or you can export them as undistorted images if you're going to bring them in through a CSV file. So you have several different choices for exporting data. All right, so if you have a question, now is a good time to start typing those in the comments if you have access to that, which I think you do. Let's see if any questions come in or comments. So far, I've either done an amazing job explaining this, or everyone's stunned into silence by how easy this is. It's just browsing through these images. Okay, still no questions coming in. That's fine. Their hands raised. Okay. Well, that's great. All right, so this photo is really lagging as I jumped ahead a bunch of images. So it's a good time for me to switch back to my prepared PowerPoint slides while it loads. So to wrap it up, here are my contact details. That's my email address, jfrance@riegelusa.com. I will be hosting my next webinar in this series of informative talks, I hope you'll find. Ooh, there are questions. Okay, how do I get to them? Ah, that's my fault. I didn't see these. I apologize. You've been sending them out. Okay. New to using everything here. All right. Okay, so but let me finish my train of thought before I get to the questions. We have our next webinar will be on the 27th at 11 a.m. until 12 p.m. Eastern Time Zone. This one I assume will bring even more questions about and this is mainly about the Scan Data Alignment Tool, or the SCAL tool, for those who know it. This is a follow-up and closing requirement or request from the training symposium held last October. All right, so yes, this recording will be out afterwards. So yeah, it will be. All right. So the new release is going to be this functionality will be available in the next release. So if you would like a copy of it, send me an email, and we'll also try to send it out as we go here. Sorry, just got to read some of these questions. All right. So the mask that this creates. So someone asked if that mask crops out the image. So what it's doing is just hiding that portion of it. That's very useful for colorizing the data. If you crop out the vehicle body, for example, it's cropping it out. So that's why we had two settings, one for analysis and one for image processing. So if you have a car body, you want to crop that out to remove it from this data set. Another good question is, most of our users were given a gray card to use with the system. If you are finding that helpful to allow you to best pick out the lighting, the exposure and gain value before you start scanning, then yes, you should still do that. If you're just doing it to check a box off and you're not going back in and adjusting the camera settings from the exposure and the gain value, then no, it's not all that helpful. I personally don't use it. All right. So with another question is, does this setting apply to the Ladybug camera? Yes, it would do that, but I would recommend you not using it for the Ladybug camera, as those images are already processed by FLIR/Point Gray ahead of time, and they're a little bit better color balanced, typically, I find, especially the ones that are the Ladybug 5 Plus. So they're pretty balanced across the full 360 view. All right. This is a really good, interesting feature request. I'm not sure how we would do it, but I'll answer it. So is there a tool for quality control on real time during the data capture in order to identify big issues with the picture's blur/overexposure? Well, the biggest quality assurance method we have available is the operator of the system, where they are seeing the live feed of the data as you are collecting. But at this time, there's not an automated feature that warns you about that as you go. Yes, this feature should work with Nikon cameras as well, as the Nikon cameras have similar properties. At this point, this feature, so the next question is, can this do similar adjustments in RiScan Pro? At this time, this functionality is not available in RiScan Pro, but a great feature request. I'll make sure I pass it on. All right, we already answered that one. Thank you, Ben, for the compliment. Sorry, just working my way through here. So someone asked, what is the benefit of this over Photoshop? I think the main benefit of using this over Photoshop would be that it's within the same program, so you don't have to take the data outside of the RIEGL environment and do additional data processing. All right. So our RiPROCESS is using, so a question was, does it take the raw format of the camera images, I think is the full question. This uses the raw format of the images, and it does do, it does use that. And then we export a TIFF or a JPEG at the end of it. So someone wants to know if there's any ability to automate the export of the images. The exporting of the images, I think, is pretty straightforward in that you can select all the records that you want to export, and then you can export them fairly manually. It is a manual setup task, but it's pretty automated to do. But get in touch with me since I want to make sure I answered that properly, if that was your question. All right. So with the image mask that you create for the photos, that's what the question refers to. Those are done for the whole series. So it's really mainly for cutting out the vehicle. Okay. So once again, I can release this beta version to anyone that requests this as long as their maintenance is up to date. Just send me an email and I'll zip it out to you. All right. All right, well, if I didn't get to your questions yet, and you're still on the line, I'll try to get to them here. Let's see here. And I'll also try to answer them later on as well. I think there's perhaps some of these questions might be better left for a separate webinar on importing camera data and how to address certain things. Sorry, just reading through the final questions here. So I think I answered most of the questions in a roundabout way for some of them, as they were part of other answers. I think the final one is that, yes, you can export the camera. So one final question is we do exports for many different third-party software modules, whether it's Topodot from Certainty 3D or Orbit GT. We do export into that, and we'll work with anyone that has another one they would like us to do. If it's possible, we'll make sure we include that as well into our exports. So if you're still with me and you have a moment or two, I can show you real quick the export functionality. Oh. No live demos finished without at least one error message. Because we got a lot of questions about export. What you can do with the export, you can just right-click on the camera record and go to export, and then you get all of this information that pops up. And you can select which type of export you would like. You can select the camera depth as well as the location of it, and then you can also create how you'd want it named. And then you have different things like we have an Orbit file, a Teraphoto file, or a Topodot file, along with the KML file. So of all those different things, and you can also select your project coordinate system in which you want the data exported in. All right. So that's a little bit extra. Once again, thank you all for taking some time out of your afternoon and your schedule to be with me here on our webinar series. I appreciate it very much that you took the time to come, and I look forward to hearing more questions from you. And I'll see you on April 27th, so to say, for my next one on the Scout tool. Thank you, and have a great afternoon.